The formation of Earth is part of the larger story of the formation of our solar system, which occurred approximately 4.6 billion years ago. The process is believed to have occurred through the following steps. Solar nebula. The solar system began as a giant rotating cloud of gas and dust known as the solar nebula. This nebula was composed mainly of hydrogen, helium, and small amounts of heavier elements. 1. Gravitational collapse. Some event, such as a nearby supernova explosion or a shockwave from another star, likely triggered the collapse of the solar nebula. As gravity pulled the gas and dust particles together, the nebula began to shrink and spin faster due to the conservation of angular momentum. 2. Accretion. The shrinking and spinning of the nebula led to the formation of a rotating disk of gas and dust surrounding the young Sun. In this disk, particles began to collide and stick together, a process known as accretion. Over time, larger and larger clumps formed through these collisions. 3. Planetesimals. The clumps of matter continued to collide and grow, eventually forming planetesimals, small planetary building blocks several kilometers in size. 4. Protoplanets. The planetesimals, in turn, continued to collide and merge, creating larger bodies called protoplanets. Earth's formation. As the protoplanet that would become Earth grew in size, its gravitational pull became stronger, allowing it to accumulate even more material from the surrounding disk. 5. Differentiation. The interior of the growing Earth heated up due to the energy released from the impacts of accreting material. This heat, combined with the decay of radioactive isotopes, led to the differentiation of Earth into layers: a dense metallic core, a mantle, and a crust. 6. Formation of the Moon. Around 4.5 billion years ago, a Mars-sized object collided with the young Earth in a cataclysmic event known as the Giant Impact. The collision caused debris to be ejected into space, which eventually coalesced to form the Moon. 7. Continued evolution. After the formation of the Moon, Earth continued to undergo processes such as volcanic activity, tectonic plate movements, and bombardment by asteroids and comets. These processes contributed to the shaping of the planet's surface and the development of the atmosphere and oceans. Over billions of years, Earth evolved into the planet we recognize today, AIC world with a diverse and complex biosphere, making it a suitable habitat for life as we know it. 1. How were continents formed? The formation of continents is a complex geological process that occurred over billions of years. It involves several key mechanisms, including plate tectonics, volcanic activity, erosion, and sedimentation. Here's an overview of how continents were formed. 2. Plate tectonics. The Earth's outer shell is divided into several large and rigid plates that float on the semi-fluid asthenosphere beneath them. These plates are in constant motion, drifting at rates of a few centimeters per year. The movement of these plates is known as plate tectonics. 3. Continental drift. The theory of continental drift, proposed by Alfred Wegener in the early 20th century and later developed into the theory of plate tectonics, suggests that the continents were once part of a single supercontinent called Pangaea. Over millions of years, Pangaea began to break apart, and the continents started to drift away from each other. 4. Divergent boundaries. When tectonic plates move apart, they create divergent boundaries. In such regions, molten material from the mantle rises to fill the gap, solidifies, and forms new oceanic crust. These boundaries are often associated with mid-ocean ridges, where new crust is continuously generated. 5. Ocean formation. As the plates continued to move apart, new ocean basins formed between them. For example, the Atlantic Ocean was created as the Americas drifted away from Europe and Africa. 6. Subduction zones. At some plate boundaries, one plate is forced beneath another in a process called subduction. When an oceanic plate subducts beneath a continental plate, it can lead to the formation of mountain ranges and volcanic arcs. 7. Accretion and island arcs. Subduction zones can also create island arcs, which are chains of volcanic islands that form as magma rises from the subducting plate and erupts on the surface. 8. Continental collision. When two continental plates converge, neither is dense enough to subduct. Instead, the plates crumple and deform, leading to the formation of massive mountain ranges like the Himalayas. 9. Erosion and sedimentation. Over time, natural forces like wind, water, and ice erode the continents. The eroded material is transported by rivers and deposited in other areas, forming sedimentary layers. Sedimentary rocks can build up and create new landmasses. 9. Geological timescale. The processes involved in continent formation are extremely slow and occur over geological timescales. It took hundreds of millions of years for the continents to form and acquire their current shapes and positions. It's essential to note that the formation and movement of continents are ongoing processes. Plate tectonics continue to shape the Earth's surface today, with continents slowly drifting and reshaping over vast periods of time.